Hello students, let us solve this question from chapter Current Electricity. The question says, in the diagram, resistance between any two junctions is R. Equivalent resistance across terminals A and B is. So in this diagram, given the resistance of any two junction is R, and equivalent resistance has to be calculated. So in this A and B, and we have to calculate the equivalent resistance across these points, and each section has resistance R. R is here, R is here. Each section has resistance R as indicated here. So first of all, consider this triangular portion of this given area. So the resistance, these two resistance are in series. So this equivalent resistance can be written as R equivalent, or let us denote it as R1. In the given diagram, the resistance here R is connected in series. So the equivalent resistance will be sum of the two resistance, that is 2R. So this is the equivalent resistance of the two resistance in series, and the 2R resistance is in parallel with resistance R. So the equivalent resistance of the upper triangular shape will be 2R into R divided by 2R plus R. So this will become 2R square divided by 3R. R will be cancelled, so 2 by 3R. So each triangular shape, that is this triangular shape, has equivalent resistance of 2R by 3. Similarly, this R and this R is in series, and this R is in parallel to each other. So this triangular shape will have equivalent resistance 2R by 3. So we can redraw this diagram as, so the three resistances can be drawn as single resistance R of value 2R by 3. Now again this resistance has value 2R by 3, which is connected with resistance R. This is B point, and connected here with resistance R again, and this is connected with resistance R. So this is point A, this is point B. Now this 2R by 3 resistance and 2R by 3 resistance is connected in series. So the total resistance of the series resistance is 2R by 3 plus 2R by 3. So that will become 4R by 3. So here total resistance is 4R by 3, which is connected in parallel with R. So this triangular shape will have equivalent resistance of 4R by 3 into R divided by 4R by 3 plus R. Let us further solve this. Here we can get 4R square by 3 divided by R can be taken as common, 7 by 3. So this 3 will be cancelled. So we are left with 4R by 7. 4R by 7. This 4R by 7 is the equivalent resistance of this triangle. Now further we can solve this triangle. Further, we can draw all the resistances as given here. Now this resistance has, this triangular shape has equivalent resistance of 4R by 7. So here we can write, this is point A, this is point B. This side resistance R, this side resistance R, and this resistance has value 4R by 7. Now again 4R by 7 and this R is in series to each other. So the series resistance will be equal to 4R by 7 plus R. So that will give you the value 11 by 7. Okay, so here this is the series resistance is 11R by 7, and this resistance is again connected with parallel to the resistance R. So now the parallel resistance with resistance R can be written as, this is the equivalent resistance of the circuit, so that can be written as 11R by 7 into R divided by 11R by 7 plus R. Further we can solve this. So this will become 11 by 7 R square divided by 18 by 7 R. So R will be cancelled and this 7 will be cancelled. So the equivalent resistance will be 11R by 18. This is the equivalent resistance of the given circuit. So which option is correct? 11R by 18. Fourth option is the correct answer to this question. Hope you found the solution understandable. Thank you.